Kubernetes and GKE Part 39. This episode has 2 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain overlay networks. Here's a strong way to approach it. An overlay network in Kubernetes is a virtual networking layer built on top of an existing physical network that enables communication between pods across different nodes by encapsulating and tunneling traffic. It is commonly used in Kubernetes to enable pod-to-pod communication across nodes without requiring direct physical network connectivity between all pods. Core idea: an overlay network creates a virtual network on top of the real network so pods can communicate as if they are on the same network, even if they are on different machines. Why overlay networks are needed in a Kubernetes cluster. Pods run on multiple nodes. Nodes may be in different subnets or networks. Direct routing between all pod IPs is not always possible, so overlay networks simplify cross-node communication, avoid complex routing setup on physical network, provide a unified pod network. How overlay networking works: high-level flow. Pod A, Node 1, encapsulation, VXLAN or IP in IP, physical network decapsulation. Pod B, Node 2, key concept, encapsulation. Overlay networks wrap original packets inside another packet. Example, inner packet, pod-to-pod communication, 10.244xx. Outer packet, node-to-node communication, 192.168xx. Common overlay techniques. 1. VXLAN, most common, encapsulates layer 2 Ethernet frames inside UDP packets, works across layer 3 networks. 2. IP in IP encapsulates IP packet inside another IP packet, simpler but less flexible than VXLAN. 3. GRE tunneling, generic tunneling protocol, less common in Kubernetes. Where overlay networks are used in Kubernetes. Overlay networks are implemented by container network interface plugins like Flannel, WeaveNet, Calico. Can work in both overlay and routed mode. Cilium often uses EDP instead of overlay. Overlay network example: without overlay, Node A cannot directly reach pod IP on Node B. With overlay, Node A encapsulates packet, sends to Node B decapsulates and forwards to pods. Simple analogy: think of pods equals cars, nodes equals cities, physical network equals highways between cities. Overlay network equals a courier service that picks up a package in one city, puts it in a truck, and delivers it inside another city seamlessly. Overlay versus underlay network feature. Overlay network, underlay network layer, virtual physical purpose, connect pods, connect nodes. Complexity: simple for apps, complex routing control. Software-defined hardware or network config benefits: easy cross-node communication, no need to modify physical network, works in cloud and on-prem, supports dynamic pod IP, simplifies Kubernetes networking. Limitations: extra latency due to encapsulation, additional CPU overhead, debugging is more complex, MTU issues can occur, packet size overhead. Best practices: ensure correct MTU settings, monitor network latency, use modern CNI plugins. Cilium for performance. Prefer routed networking when possible in large-scale clusters. Test cross-node traffic in production-like environments. Interview-ready definition: an overlay network in Kubernetes is a virtual networking layer built on top of an existing physical network that enables pod-to-pod communication across nodes by encapsulating and tunneling network traffic, allowing a unified and scalable networking model without requiring changes to the underlying infrastructure. Nice. Let's continue. Question 2. What is Calico? Here's a strong way to approach it. Calico is a high-performance networking and network security solution used in Kubernetes to provide pod networking and enforce network policies using a scalable, routing-based architecture, and optionally overlay networking. It is one of the most widely used container network interface plugins. Core idea: Calico enables pods to communicate securely across nodes using routing, or overlay, while also enforcing fine-grained network security rules. It combines pod networking, connectivity, network security, policies. Why Calico is used: it helps to provide pod-to-pod networking across nodes, enforce Kubernetes network policies, improve network performance and scalability, replace complex overlay networks with routing, BGP-based, support large-scale production clusters. How Calico works: Calico operates in 2 main modes. 1. Route-based, preferred, uses BGP, Border Gateway Protocol, no overlay tunneling, direct routing between nodes. Pod A, Node A, BGP routing, Node B, Pod B. 2. Overlay mode, optional, Uses VXLAN encapsulation used when BGP is not possible. Key components of Calico 1. Felix. Agent. Runs on each node, applies routing and network policies to BGP. Optional. Exchanges routing information between nodes. 3. Taifa. Scaling component reduces load on Kubernetes API server in large clusters. 4. CNI plugin assigns IP addresses to pods, sets up networking rules. Network policy enforcement. Calico is powerful in security because it supports Kubernetes network policies. Allow or deny traffic between pods, control namespace communication, restrict ingress or egress traffic. Example: network policy API version, networking K8SIO or V1 kind, network policy metadata, name, allow GINK spec, pod selector. The exact commands and code are in the written question bank. Great, moving on. That wraps up this episode. Nice work practicing, and see you in the next one.